So make your parabola, so we're going to bend it. And so what's important about a parabola? Yeah, that the bottom is curved, not pointy. So did anyone make the bottom pointy? You're wrong if you did that. And you would get marked wrong if that bottom is pointy, okay? Where's the pointy graph? Right here, do you see it? It looks the same and it works the same. Graphing them is identical. We would have like a vertex there where the bottom point, but you'd fold your pipe cleaner and make it pointy. Okay. Now these are the general ones right here. Let's see if we can get it to stay. There we go. Okay, so those are those two. Do you agree? Now do yours look like that? Now what happens, so we talked about this one already, if the slope is a steeper or positive number, it goes up like this, steeper, and what if it's a fraction in front of the x, what would happen? It wouldn't be as steep, so it would be closer to the x-axis like that. Now what about this, what if there's a number in front of that, what happens to it, any ideas? Like a 2 in front of it. What happens to this? So if you read your textbook like you're supposed to, you would know. So we can call this one of two things. So this, if it has a 2 in front, it goes like that. Okay, skinnier. So I call it skinnier for a parabola, but it could be called either a vertical extension, so it's stretched in the vertical direction, or horizontal, what do you think? I did it horizontally, because I'm coming from the sides, that's horizontal. I did a horizontal compression, like that, but it could be called a vertical, so I have to come from the top. I'm just going to hold the vertex here. So just to hold that in place. If I pulled it up from the top, that would be called a vertical extension, right? Pulling it up. And if I pushed it in from the sides, that's horizontal. So those two things sort of mean the same when it comes to a parabola. But that would be a positive number. What do you think if there was a fraction in front, what would happen? So, yeah, it comes out this way. So we could call that a vertical, or I came from the side, so horizontal extension, something like that. Okay, the name itself doesn't matter so much. And in fact, your points that you find that we did before will determine how skinny or wide it is, but just so you know. Now what if there was a negative in front of that? We already learned, so what happens? It flips this way, right? Okay, so all the other graphs do the exact same thing, okay, and they're all sort of in that completed square form already. So we don't have special formulas or anything. What I want you to do is make this shape. I'm not going to make it. I'm going to let you try, because this cube is the one everyone gets wrong. So make it with your pipe cleaner. Okay, so does everyone have their shape? Now, does yours look like an S? That's my question. Look at it, then it's wrong, you'll get it marked wrong. So what does an S look like that this doesn't? People make an S all the time. So if you bent it up and then bent that side down, see that kind of is like S shape? That's not right. What happens on the ends? They keep going in this direction, like a parabola. In fact, both of these sides are the same shape as a parabola. So if you took your parabola, hold it at the vertex, okay, and just flip that side down, then you've got your cube. It's a half a parabola up and a half a parabola down. And then all the same rules apply. So what if it was, so here's our parabola, what if the y-intercept, or our cubic, what if the y-intercept changes? What would happen to it? So the y-intercept right now is what? 0. So what if the y-intercept was 1? It moves up 1, but the shape, the steepness doesn't change, just like our linear equation. It stays the same. So it's like you're picking up the shape and moving it to a new spot. So if it was 2, 3, or down negative, right? What if it had a minus in front? Yeah, now this is, I don't want it to move. I still want it to look like a half parabola up and down, but the whole thing flips. So it would go this way instead. Do you see it? Now you have to practice drawing this, that it doesn't look like an S. So the way I draw this, when I do it, is we're going to find that vertex. I'm going to show you how to find that. We're going to call it the center, because it's not really a vertex anymore. That's only for parabolas. You're going to find that center, and then from that center, if it's a positive shape, if it's normal, the normal way, you're going to go from there and draw half a parabola up, and then go back to that center and draw half a parabola down. What are you not going to do is try to start down low and do this. What happens, I find, if you do that is they don't look like parabola pieces anymore, they look like an S. If you try to make it in one shape, people tend to kind of come back and curve a little bit this way, and then it's wrong. Okay? So we're going to find our center, half parabola up, half parabola down. Now what is this one, do you think? Go back to your parabola. Now, instead of doing it your way that you did last time, do it my way. Take your parabola graph and make this one out of it. So it's still half a parabola, but which way is it going? So instead, take that parabola, we're going to move it over here. So there's the top. And then if you hold that center, we're going to flip that side over. Here we go. And again, if the intercepts change, all this does is takes this exact same graph and moves it to a different spot. So what do we need to know to draw any of these graphs is that center spot. So which spot is important for each graph is that center. Then we're going to do a half parabola on its side. And what about the negative one? Flips. Okay. Now, what about root x? That was the cube root. Same as the cube, but it's on its side. This is the same as the squared, but it's on its side and there's half of it missing. Because you can't have a negative under a root, so we can't plug in negatives under the square root, so we end up with only half of the parabola. So how could you do that? Easy, and this is, we'll still call it the center, but it's this little point here that's important. Once you get that, and you know that it comes from that. Now the square root's actually the most confusing one to draw with the negative signs. Okay, so here it is. Actually, let's do my parabola. And then it's on its side. That's not a function if we have the bottom. We can't have negatives under the square root, so it's only half of that. So here it is, half. Cool. Now what if it's negative? Negative flips down. Okay, this would be negative, just, not the top one. Now the thing with this one is we can actually flip it this way. If there's a negative in front of the x under the square root, which means you can only plug in negative numbers, but it can have a negative in there. And if you have a negative in there and out there, it will flip this way. So there's 4 choices, and I'll show you all of those on paper in a minute. Okay? Now what about this one? This has a name. Hyperbola. Now, I talk about all the shapes. I've told you this with my kids before, and the babysitter got mad, because, or the babysitter didn't get mad. My friend got mad because her kid didn't know as much as mine. The babysitter needed me to write down all the shapes because the kids were saying things like rhombus and at daycare and getting everyone confused. So, this is not a parabola. Okay, this is a hyperbola. Where do we see a hyperbola in the real world? So this is what my kids come in. We find hyperbolas everywhere. The skateboard park? Do you see it? It's a ramp? Yeah. So this shape, picture this as like a skateboard park, okay? Let's get some nice shiny ones here. Okay, so these are the center for this graph. Every other one we draw a point and then the graph from the point. For the hyperbola we actually need to draw both the x and y. What are those called? The axis, but in a hyperbola. You probably have seen this, well definitely you've seen this before. What are they called? The lines that a hyperbola goes up against but not through. The asymptotes. Do you remember asymptotes? Okay, so here's our x and y axis. But what happens in a hyperbola if we draw the equation and we add some numbers to it is that these axes move. That's what happens with this graph. Where all of these ones, it's that center point that moves and then we draw the shape. With the hyperbola, the axis actually moves. And those are the x and y intercepts, so we're going to do that this one next class. We won't get to this one today. And then the hyperbolas, think of a skateboard ramp. They go along it, they don't go through, and they get really, really close to it. And unlike a skateboard ramp, but still, if you zoomed in on the end of a skateboard ramp, is it ever in the ground? Like, it touches the ground, but does it lay on top of the ground? No, it doesn't ever quite get there. There's still, even if they made it really, really thin on the end, there wouldn't be much of a drop when you skate down, right? It could be smooth, but that bottom of the ramp is not in the ground, right? It's above the ground still. So it goes to these asymptotes, but never touches. So it gets really, really close. And the farther you go, the closer they get, or the thinner the end of the ramp becomes. But it doesn't actually ever cross or even go to it, right? It gets close to it. So these pieces, if I drew it like this, that's totally wrong, because why? Do you see this end? Is that getting closer and closer to the ground or the... No. What does it have to do? Like this, and those ends will look like they're touching, and in fact, when you draw it, you can make them touch that line, okay, on the ends. But they don't curve back around like a parabola, so they don't do this. Okay? See the difference? Okay. Or let's draw them. So it never ends, yeah. It's a never-ending skateboard ramp. Okay. Yeah, so like the center point or the vertex is the x and y intercepts, and then we draw it to that. Yeah. Okay, so but we won't do that one until after. What we're doing today is all the rest of these, because the rules work the same for them. It's just we take that shape and move it around. Okay. So on the final, sometimes I ask just for the basic graph. What's the basic graph of a cube? And I want you to draw that just in the standard position, which is just on this page. Okay. But then we're going to shift them around. So if you read your textbook, the important parts is finding the center. So the center, it's like the vertex, and if you call it the vertex, that's okay. All right? It's not really the right word for it. It doesn't have a right word. Maybe different for each graph, but we're just looking for that important point, and then we draw the shape off of that point. So let's do an example for a cube, because we didn't do any solving for cubes. So we'll do a couple of cube graphs. So for the regular basic graph of x cubed, we draw the center, and then it's a half a parabola up and a half a parabola down, and you're done. So you start at that center. Now, what happens if we change the y-intercept? So that's what this is doing. Adding a number or subtracting a number on the end of the regular x cubed I didn't change the slope of it, but I didn't put a number in front of the x cubed. Okay, I didn't change the slope of it, so it's this exact same graph. So if you've got your x cubed graph, it's the exact same graph, but instead, this moves it up 2. So this graph shifted up 2, half parabola up, half parabola down. Now, what you're going to have to do, this is enough for calculus, drawing the graph sort of in the right spot. Now, what I said for in here that's really important is to make sure that it crosses the axis in the right place. So, that's the points that we need to find. How do we find this point right here that it crossed? What axis is that? So this would be the x-intercept. What do we do to find the x-intercept? Let y equal 0. So the difference with we're not factoring these, so they're always going to work out nice. And a cube root can have a negative under it, remember. Cube root can be negative, any odd root can be negative. So if we move the 2 over, x cubed. Now how do we solve this? So this is a cube, so we take the cube root of both sides. There's no plus or minus to remember or anything like that. We don't factor these. So the cube root of x cubed, these cancel. So this would be x is equal to the cube root of negative 2. Who knows what that is? It's not one we know. What cube roots do we know? This is 0. This is 1. What's the next one we know? 8 is 2. So where is this? Oh, and let's put the negatives. So they can be negative, because negative 2, we did these before. Negative 2 times negative 2 times negative 2 is negative 8. They can be negative. So this one is really close to negative 1, but bigger or smaller? Bigger or smaller, depending on what you're thinking, but between negative 1 and negative 2. So what could our guess be? Negative 1.2, whatever. Okay, it doesn't really matter because you're drawing it on the graph, and what you put on the graph is the exact value, not your guess. So here our y is 0, and our guess is the cube root of negative 2. Is our exact answer, not our guess on the graph. And what was this point? I already wrote it on. That was my center. And then that's 100%. Okay, so that's if it moves up, and moving down is the same thing. But what if we put something, let's label these. Okay, so and this is what I mean by like the completed square form. So we could have a bracket with a cube, so you know it's a cube. And so think back to parabolas, they work the exact same. What is the vertex if this were a parabola? Negative 1, negative 8. So that's what we're going to call our center. So same way as we found the vertex. And then you can find your x and y intercepts. But don't just do it blindly like we did for draw the graph first and then say which one do I need. Okay, so here I usually say, okay, well here's my basic graph. This is x cubed, half parabola up, half parabola down. Does this one flip? Is there a negative in front of that bracket? No. So now we're going to our center. So we're going to find the point, negative 1, negative 8, 2, 4, 6, 8. This is our center. Otherwise, the graph is the same. What you're looking for to know if it flips or anything like that is a negative. Okay? Otherwise, it's this graph, like you're picking up your graph and just moving it to be at that point. Okay? So you're drawing the same graph. Now, I'm going to be careful here. I'll draw it in pink because I don't know where it goes through here, but half parabola up, half parabola down. Okay? But I just drew it in pink. I'm going to make it darker in a minute. Which intercept do I need? Right, it's going to cross the x up here somewhere and the y here. Yep, so the x-intercept, we let y equal 0. Now be careful you don't try to factor a cube. We're not factoring, we're just solving by, we would move the 8 over. How do we get rid, not square root, cube root, both sides? That cancels that out. We do the cube root of both sides. Oh, thank you. I don't know. I don't know why there's a 3. There we go. That's the whole thinking and writing thing. Okay, now what? Did you see how I got from here to here? When you take the cube root, it cancels that out. So, and then move the 1 over. So the cube root of 8 minus 1 equals x. What's the cube root of 8? So x is 1. Write it as a point. So 1, 0 is here. Now the y-intercept, we're going to let x equal 0. So y equals 0 plus 1 cubed minus 8. What's 1 cubed? 1. These are the kind of things that I'll write a graph for my daughter in this form. I do a little table of values, and I get her to plug in different numbers and then plot the points and see if it looks like the basic graph. So order of operations practice. 1 cubed, 1 minus 8, negative 7. I have a son, but he doesn't care, right? So we don't talk about him. He's into hockey. He scored his first goal, or not his first goal, the first goal of the season in the game on the weekend. So, and I cried, because I cried everything. You laughing at me crying? I'm crying for my son, and that's okay. I cry for everything. So in Walmart on the weekend, was anyone there? Because you'll know exactly what I'm talking about if you were there. Is anyone there? So there was a kid that was having a fit. Something was wrong with him, obviously, and the mother was laying on top of him, and he was screaming, and I started crying. It was bad. They called the police and everything. If you were there, you know what I'm talking about. It was very scary. And I started crying, and my daughter says to the other person, like, don't worry, she always cries. Okay, so basically the idea is the same for every single cube. You do the same thing. You just move it around, okay? And I can show you a million examples, but you have to practice and then check your answer. That's really what you need to do. So you have to go to that section in the textbook and practice them. There's a bunch there. And the answers are there, so then you can look. So let's just do a negative one to show you that. So this is what it would look like when there's a negative, and what happens to that is that it flips. So if you drew your basic graph, x cubed, half parabola up, half parabola down, what would negative x cubed look like? Same center. The other way, so it goes half a parabola on this side and half a parabola here. Again, don't try to start from the top and make like that S shape. It's a half a parabola shape from the center. So do you see that this is flipped? So when we draw our graph of this one, it's going to be modeled on this. And then we need to find our point. So what is the center? -2 and 8. The negative does not factor into the center, that only flips it. So -2 and 8. -2 and +8. 2, 4, 6, 8. Now, let's go to the pink, the light color. So, normally it would go half parabola up this way, but we're going half parabola up and half parabola down. So it's going to hit somewhere in here, just lightly, because you want to make sure it crosses the right spot. So we'll put that might not be the right spot. Okay? but it's this way. Half parabola down, half parabola up. And that's in pink because I'm going to fix it in a second. So what do we need? X and Y intercepts. You could do them first if you wanted to, but I find if you put too many points on the graph, then you're trying to connect the dots rather than drawing the shape smoothly like a half parabola up and down. Put the center only, and then just lightly in your pencil draw the shape. Then find your points and put them on, okay? And then you can fix it to go through. But you want your shape smooth and not looking like an S. So the x-intercept, we let y equal 0. So what will we move to the other side this time? The x plus 3, because it's negative, so we move that. And what's it called when we put that cube by itself? Do you remember? Isolating it. We're isolating the cube part so that we can do something to both sides. So you get it by itself, take the cube root of both sides, which you can show on this side or not, it doesn't matter. Cube root of 8, I keep putting 8 because the numbers are small. Now be careful, when there's the same two numbers, people make silly mistakes. What's this? 0? Okay, does my graph go through 0? No, so I have to fix it. Okay, this is the point 0, 0. What about the y-intercept? X equals 0. Yeah, there's not 2 here. There can't be 2. There's only ever one of each with the cube, unlike a parabola, because the parabola goes back up. I don't have a parabola here, but a parabola could cross the x twice because it goes up, but a cube can only cross once. Okay, so there's only ever one. If we let y equal 0, we'll get negative 0 plus 2 cubed plus 8. Negative is in front. 2 cubed? 8 plus 8, which is 0. So we already knew that, but it's verified. Okay, so now we have to fix our graph. So you could, if you did it in pencil, like I suggested, then you just erase it. This has to go through here. So your half parabola down, make it look like it's going through 0, 0, and then your half parabola up, but still at that center. Okay? Okay, so that's for cubes. Then you just need to go and practice a few. The numbers can change, but essentially the work is the same. We're just drawing that same shape in different places. So let's go to a cube root. So how does this one differ? It's actually the same shape, but it's on its side. So our center, half a parabola on its side, and then half a parabola. There we go. And when we're solving it with the cube, when we were solving, we took the cube root of both sides. Now we're going to have a cube root, so what do we do to both sides? Cube it instead. So the number gets bigger rather than smaller. So now look carefully how you wrote it. 2 is a big number in front. That's the coefficient. The number multiplied by the cube root, that's a little cube there. X plus 1 is under the cube root, and then minus 2. Yes, your center is still negative 1, negative 2. Now what does that 2 do in front? That is like the slope. It's like mx plus b. It changes the steepness of it. So this is going to stretch it up. Right? So, but you don't need to worry about that because your points will dictate what it looks like. You just need to have your center and then your x and y intercepts, and it will be higher or steeper. Okay? So there's our center. That's what we would draw first. Now here's our basic graph. Is there a negative in front? No, so it's the same basic graph. our center is at -1 and -2. And lightly in pencil, draw your shape. So this will be a half parabola up and a half parabola down. Probably going through in the wrong spot, so I'll have to move it in a minute. But that's the idea. If you had the basic graph, now this, if that 2 wasn't there and you took your pipe cleaner of that basic graph and you just wanted to move it, the steepness doesn't change, so it would actually be accurate where you put it through. If you picked that up and you moved it to its new spot, that 2 in front, what it does is changes the steepness, so the points will change, it stretches it. Okay, so that's the only difference, but the shape still looks the same. So this could actually go through negative if it's stretched up high enough, or maybe at 0, so let's try it. So our x-intercept, we're going to let y equal 0. Okay, so how are we going to isolate the cube root? This -2 moves first, because there's 2 terms here, right? 1, 2. Get rid of the one without the cube root in it. This is back to like almost this is the back to the first day of class, right here. Right, we want to isolate the cube root, so we don't want the 2 in front, so how could we get rid of it? Divide both sides by 2. So 1 equals the cube root of x plus 1. Now we've got the cube root isolated. How do we get rid of it? Cube both sides. Cube of 1 is still 1, so that's easy enough. And move the 1 over. This is 0. 1 minus 1. So if it goes through at 0, that's both the x and the y. You could check the other one. So I just need to make sure I change that. And again, just like the, we don't need to worry about this part, but it looks sort of symmetric, right? They should be the same steepness. They should sort of match each other, right? But it's our half parabola up, and we want to go through 0, 0. So you would go back and change that graph so that it goes through at the right spot. And again, you don't need to draw it lightly first, but I find people do better if they sort of draw the basic graph on and then find the points that it needs to go through. If you put the points on, what happens sometimes is this parabola no longer looks like a parabola. It looks like you tried to connect these. You forget which one's the center. This might come down, curve down on this side, like a half parabola from that. So it really, I would put your intercepts on after. That's it for the cube root, because it's just the same as the cube. If it has a minus in front, it flips, and so on. Okay? So you need to practice those. All right, next one. Let's do absolute value. And again, nothing new here. When we solve the x and y intercepts, we're solving a equation that involves an absolute value, which we did twice, lots of times. But these are all just linear ones. So an absolute value is a v. If we put a negative in front of the absolute value, what happens? Goes this way. So that's what you're looking for. Absolute value of x minus 4. What's the vertex? What makes the inside of the absolute value 0? 0. -4. Okay, so we've got our center. We're going to sketch it just roughly. 0, -4 is down here. Does this one flip? So you draw your center and always ask, does it flip or not flip? Because you want to make sure you draw that graph correctly. Does it flip? No. So it's going to be a V coming from that point. So does it have other intercepts? The x-intercepts? Yes. We let y equal 0. Again, same idea, isolate the absolute value. So what will we move? The 4. All right, do you remember how to solve these? So absolute value has two answers, the plus and the minus, and that is that it's the distance 4 from this direction and the distance 4 from this direction. It gives you 2 points. So that was the two cases that we did when we solved these. The inside x has to equal 4, or the inside x could be minus 4, right? There's nothing to solve here. We just need their two answers. So these are 4 and minus 4. Okay, we'll make it a little more complicated, so let's call that 1, 2, now this one has a 2 in front of the x, but that's in the bracket, and that does change. It changes the steepness of it. Same idea, it changes the steepness. But you have to be careful of these ones. We didn't see this one yet. What is the vertex? Not -3. Okay, so don't just look, remember I keep saying what makes the inside of that bracket 0? Usually it's easy enough to just read off, but what makes the inside of this bracket 0? So 2x plus 3 has to equal 0. What does that give us? -3 over 2. That's the x value. Okay, so be careful of that. What will some people do? Put -3 because they see that plus 3. Don't do that. Just most of the time when we have that graph, they've just got like an x plus 1. So what makes that 0 is -1. Right? There's not much to solve. You can just look at that. What makes the inside of this bracket x plus 2 0 is -2. But when it's got a different slope, then it's not quite. If we plug in -3 here, we don't get 0. So that isn't the center. So there's our center. And this, does it flip? Nope. Okay, so -3 over 2 is like -1.5 and -5. And it's a V, so it's going to go through somewhere over here, right? So just lightly drawing in your V, we need our intercept. So our x-intercept, going to let y equal 0. So are we going to get two answers here or one? Two, because that's the x-intercept, right? It's going to go through twice. So hopefully you'll remember to do the two cases, unlike in the section before when you only did one case and you get half of the marks, half of the answer. If you're looking at it, you know there's two answers, okay, for an absolute value. So move the 5. Now, case 1. The inside of the bracket is equal to 5. And then what's case 2? -5. So solve each of these. X equals 1, so this would be 1, y is 0. Here, -5 minus 3, x is -4. Okay, so 1 and -4, sure, those look okay so far, but let's get the y-intercept. Be careful of these. This is the absolute value of 3 minus 5. Absolute value of 3 is 3 minus 5, -2. So -2, a little bit off. Okay? It also will help you when you're doing this, if it looks like totally off or the points are on the wrong side. Maybe you say, oh, well, how come the points are down here below instead of above? Well, maybe it was supposed to flip and you forgot to flip it. So doing the points will help you to check your answer. Either your points are wrong or you forgot to flip it or something like that. Okay, let's do one more absolute value and then we'll go. Lots of minuses here. Okay. So what first? Center. What makes this 0? 3. -4. Now I made this with a flip. So our regular absolute value, this is absolute value of x. We want a flip, so it's going to be this way instead. Okay, so when we take our center, 3, -4, it's going to go this way. What does it not have? It doesn't go through the x-axis, so we wouldn't need to check that. But I do want to show you that because this is where some people go wrong. I'll show you what happens if you went to find them, okay? When does it not exist? And it does go through the y. So let's say we were to find the x-intercepts. It doesn't have any. We can see that from the graph. But if you messed up this point and you're trying to find them, let's do it. So we're going to let y equal 0. Isolate the absolute value, so bring the, well, let's bring the absolute value over, because it's negative. So far, so good? Oh, no. So far, so good? Okay, now what? Divide by 2. We don't want anything with the absolute value, so divide both sides by 2. So we'll absolute value of x minus 3 is equal to -2. Now, what does this mean? This was one you had to catch. There was no rule. You could do it wrong and do case 1, case 2, but an absolute value is a distance. And can a distance be negative? Can't be negative. You just have to get used to seeing that. If you see absolute value equals a negative number, that doesn't exist. You stop. Just like if you see a negative under the square root, you know enough to stop. You don't keep going. You just say you can't have a negative under the square root. This is the same thing. When you see an absolute value equals negative, you say can't happen. You don't solve it by accident. Okay? So that can't be negative. Our y-intercept, all right, so carefully here, absolute value of -3 is what? +3. So this is -2 times +3. Absolute value of -3 is +3. So we get -6 minus 4 minus 10. 0 minus 10. So this will go through at -10. And that would be your graph. Okay, so your parabola homework, you should have done those two. And now you can do a bunch of this section.